So in my last video, we talked about hash functions, okay, which was the foundation of a blockchain security as well. But today, we are stepping into something even more powerful. And this is what actually controls the ownership in the blockchain, all right? So we aren't going to see any kind of username, nor going to set any kind of passwords. We are just going to play with the keys and do stuff with the keys, okay? And let's see how this actually works. In blockchain, your identity is not your name, okay? It's a pair of cryptographic keys. One key is public, which anyone can see it, and the other is private, which only you should ever have it, okay? And this pair controls your entire digital wealth, which is your digital wallet. Now, let's jump into a private key first, okay? So, to a computer, a private key is just a random string of numbers and letters, okay? But to you, it's the only proof that your money is actually yours. So the blockchain doesn't care about your identity, your intentions, or even your mistakes, okay? So it only cares about the key. And if a stranger holds your private key, the network, the blockchain network, doesn't see a thief, okay? It sees the owners in strangers as well. And there is no manager to talk to or no any kind of fraud protection. And also no any kind of second chances, okay? If you lose the key, you lose the vault. If you share the key, you only hand over the deed, okay? And treat it with total silence because once that key leaks, your balance is already zero. Now comes the public key, okay? So this is what you share with the world, all right? So there isn't any kind of risk or fear in sharing this public key. It's designed to be public, all right? And it is generated from your private key, okay? Using a special kind of mathematics called elliptic curve cryptography, okay? So you don't need to understand the math right now, but here's the idea, okay? A secret number goes in, a completely different value comes out, okay? And that becomes your public identity, that is your public key. So people use a public key to send you crypto or verify your transactions simply. So keep this simple in your mind, okay? Private key means ownership and public key means identity. Now, you can share your public key very freely, okay? But your private key should never leave your control. And in the next video, we'll also break down the actual math behind this step by step. Now, before we dive into the code implementation part of the public and private key, let's first roughly understand this ECDSA module, okay? So this is an easy to use implementation of ECC, that is elliptic curve cryptography, which is the same mathematical stuff that I was talking before, okay? So this helps us to derive the public key from the private key, okay? And this comes with the support for ECDSA, that is elliptic curve digital signature algorithm, and many other algorithms as mentioned here. Now, as I have already introduced you the ECDSA module, now let's write the code for the private and public key, okay, for the better understanding. So I'm going to import some required stuffs from ECDSA module. So ECDSA from ECDSA import. The first one is the signing key, okay. So I'm just going to copy and paste these stuffs. And now let's get into the private key generation part. Okay, so it's pretty simple. There isn't any kind of rocket science here. So simply you gotta write private key. Okay, and as you have created this variable, now you gotta store the private key. So we gotta use the sign key and dot generate method. And we also have to specify the curve we are going to use. Okay, so we are going to use this mathematical curve called SECP, that is SEC P256K1. Okay, so we gotta mention the curve here equals to this one. All right. Okay. That was all for the private key generation. Okay. Now let's see the public key generation part. Public key equals to private key. As I already mentioned, we gotta derive the public key using the private key. So now let's see how. Okay. So private key dot get uh, verifying key, that is public key, and our public key is now stored in this public key variable. Okay. Now let's print one by one. Okay. So I have also written the print statements here. Now let's run this program. Okay. So Python public private key. All right. So as you can see, we got our private key at first, and we also derived our public key using the private key. Okay.
So just now we saw the code implementation part of public key and private key, okay? And we also saw how we can derive a public key using a private key, okay? But here's the thing to keep in mind. As we derive public key using a private key, but we can't go backwards in the same case, alright? Even with the supercomputers, it will take longer than the age of the universe to generate back the private key using a public key, okay? So this is called one-way cryptography, and it's what makes the blockchain more secure.
Now here's the interesting part. Okay. How do you even prove something is yours? Okay. And without actually showing your private key, because obviously you can't just send your private key around. Now, what actually happens is pretty smart. All right. Let's say you want to send one Bitcoin to Alice. Okay. And first you create the transaction. Okay. In the first step, you create the transaction. Just a simple message saying send this amount to that person. All right. And here in this case, send one BTC to Alice. Now, instead of sending it directly, you use your private key to sign that message in the second step. All right. So this doesn't reveal your key or anything. It just creates a unique signature, almost like your personal stamp on the transaction. All right. After signing the transaction with the private key, you gotta send that transaction along with the signature. Okay. And you gotta send this transaction and signature combination over the network, over any kind of network that you are involved in. That means it could be a Ethereum network or Bitcoin network or any kind of network. Okay. And here's the magic happens. The network takes your public key and uses it to check if that signature is actually valid or not. Okay. In this step. Okay. In the second last step. And if it is valid, that means only one thing. That is the person who signed this actually owns the private key. Okay. And once that's confirmed, your transaction gets accepted and added to the blockchain. Okay. From first to last, if you observe all the steps carefully, you never see your private key getting revealed, right? You are just using your private key to prove that it's you before the transaction gets confirmed, alright? Now let's quickly see the coding implementation of signature flow of the blockchain. Firstly, we gotta import the signing key and sec P256K1 from ECDSA module. And after that, we gotta, create the private key and public key using the same things that we have imported. And after that, the message creation part comes up. Okay, that means the transaction creation part comes up. And the message is send one BTC to Alice. Okay, we are referring this as both as message and transaction. Okay, so don't get confused in between that. And after that, the signature portion comes up here. And we have used our private key to, sign the message or transaction. And I have also printed the hexadecimal value of this signature. And after sending the signature with the transaction over the network tries to verify that, right? So for the verification process, we have created a is valid variable here that stores the boolean value either true or false. And if this comes up true, then your transaction gets added in the blockchain. And if it is false, then it gets rejected. Okay, so it is that simple. Let's quickly run this code and validate our transaction. Okay, so as you can see, the hexadecimal value of signature is this, and the is valid variable comes up as true. That means our signature is validated and transaction is added to the blockchain. Okay.
So I just want to conclude the session saying that blockchain doesn't trust people, okay? It trusts mathematics and your private key. And if you understand this, you are already ahead of many people in the crypto. And in the next video, I'll break down ECC, that is Elliptic Curve Cryptography, in even more depth. So subscribe if you want to truly understand the blockchain, not just use it. For today, that's it, and see you in the next session.